Hello and welcome to today's Medical Innovation and Enterprise undergraduate open event. Thank you very much for those of you joining us today. My name is Seta Diop. I am a current MIE, which is Medical Innovation and Enterprise student here at UCL, and I'll be your chair for this afternoon. We're hoping to make the session address some course-specific questions that you might have, and hopefully it will help you gain an insight into what it is really like to study in our Medical Innovation and Enterprise undergraduate program. So this afternoon, our speaker, Gavin Gell, will introduce you to the exciting field of medical innovation and enterprise, followed by an overview of the structure of the program available here at UCL. There'll be a Q&A session and plenty of interactive opportunities for all of you to join in throughout today's session. The session is also being recorded and will be made available following today's event. So we're here to respond to any of your questions, and please feel free to share these throughout using the Q&A function on Zoom, which we can all see, and address those questions as we go along. Now, to introduce our speaker, we have Gavin Gell. Gavin is Professor in Nanotechnology and Regenerative Medicine at UCL, and Gavin is the course director for the BSc and MSci in Medical Innovation Enterprise, so he's also my course lead. And he leads a research group who are developing our understanding on how materials interact with biological environments to create better, we put this in a little, I'll explain that a bit more in a minute, better biomaterials that have reduced failure rates and have increased functionality. This includes materials that induce regeneration, tissue engineering, and improving nanoparticle targeting. And so before handing over to Gavin, we'll run our first quick poll to see what you guys think. This should be on your screens now. And the question is, what is the most important medical innovation? We have a few options for you. The first one being stem cell therapy, nanomedicine, vaccines, antibiotics, X-ray detectors, or gene therapy. So what is the most important medical innovation that our audience here thinks? Have a go at that question and we'll reveal your answers in 1 minute. All right, how to think about that one? Let's see what our audience thinks. Okay, so stem cell therapy got 0 points, nanomedicine got 1 vote, vaccines got 1 vote, antibiotics got 2, and our winner, gene therapy, which is very interesting, got 3 votes. I'm sure Gavin will go into more detail about what he thinks about that. I already have theories, having spent the past 3 years with him, but let's hand it over to Gavin. What do you think?
What do you think, Seta?
I personally have been asked this question before. My answer was antibiotics, because we wouldn't be here today without a lot of the previous antibiotics that we've had. And I know that gene therapy is this very big buzzword that we're dealing with at the moment, but it's kind of not as far as we might think it is, but we'll see what you think. Give us more information.
I absolutely agree with you. I think antibiotics have made a huge impact. I think, as you probably all aware, that there is increasing amounts of antibiotic resistance, and we haven't been very good at creating new antibiotics. So that's certainly an area of medical innovation that we're looking into. Well, I say we, not me, researchers as a whole. Stem cell therapy, nobody voted for, which is interesting because I think we did this a few years ago and stem cells were super popular, but I think it's a little bit about the perception in the media and how much coverage different topics get at the time. Vaccines, I think you could argue they've had a really dramatic effect on our well-being as a species. Certainly, you look at COVID most recently, then without vaccines, we would have a different environment to what we have now. So yeah, I don't know. I'm torn between vaccines and antibiotics. Nanomedicine is an area of my research, and I think you always are more critical about your own areas. Okay, good. Shall I kick off my talk?
Yes, please. Oh, actually, no. Before we do, there is another poll. Go on.
I was going to say, shall we do this during the talk? We'll have a little break because I've got this slide up here. So I'll ask you at some point, Seta, to put this up. Is that okay? Perfect.
And yeah, lead us into your PowerPoint.
Right, I'm just going to share my screen. Here we go. So I am the course director and the creator of this course, Medical Innovation and Enterprise. We've been going for 4 years. I know that because Sata was in our first cohort of students that came into our degree. And now she's in the 4th year, which is the MSI. So you can do a 3-year BSc, or you can do a 4-year MSI, so it's Master of Science. So the idea of the course is really to mix business with medical science, with a strong emphasis on the skills which I think employers are really looking for, which is creativity, criticality, and communication skills. We want to have students who are entrepreneurial, that are problem solvers, and are leaders, I think, in this medical science community. You can ask me why I created this course. I think the main reason is, why did I create the course? I'm going to stop. There we go. That's better. I created the course because there's a real gap between the science we do and the translation of that science into business. And I think that's probably highlighted by COVID-19, where we needed to have rapid innovations and medical innovations. And it's not just, we had lots of technologies that were available, but we needed to get those to patients so that they would be of patient benefit. And to do that, you need to have commercialization. We have this thing called the Valley of Death, where we have lots of amazing science, especially in the UK, I think, in biomedical science. But not all of that gets translated into patients. And that's called the Valley of Death. And this is, we're aware of this from like a governmental perspective, in the EU as well. And we're trying to plug that gap between scientific discovery and implementation. And that's what the course is about. So the business side of things is delivered by the School of Management largely. And they were a well-respected, world-renowned school of business and management. And they're based in Bloomsbury. So your taught components for the School of Management are going to be in Bloomsbury. They also have offices in Canary Wharf, but I don't think that that's more masters. Sata, where do you go for the School of Management courses?
Yeah, mostly based in Bloomsbury and in the IOE, the Institute of Education, which is one of our buildings that we use. They have a few things that they run at the Canary Wharf office. I was participating in one of their kind of optional programs this year, which they're hosting kind of a networking event at the Canary Wharf, but it's very exclusive, only for a few sessions, a few times a year.
Very nice Canary Wharf office, aren't they? Good. So we have the business component there, and they're obviously experienced in delivering this business. There's, in London as a whole, we have an amazing network of enterprise. Both within UCL, we have the UCL Innovation Enterprise community, but London is obviously a big city, but as a real hub for enterprise in medical innovation. And we're trying to connect to that wider community. UCL itself has been pretty successful with UCL biomedical kind of spin-outs and medtech spin-outs, especially in the cell therapy kind of area. And these are some companies which recently were bought out by large companies. And obviously medical innovation is making a real difference at the moment. There's lots of different medical innovations that are happening. We're very interested in digital healthcare. We have the UCL Centre for Artificial Intelligence, and one of those arms is investigating ways where we can use digital healthcare to improve therapy techniques. So that could be in terms of improved diagnosis, and also personalized medicine as well. We also have collaborations with the Faculty of Law. So if we want to have medical innovations to get to the market, to get to patients, it's important to understand a little bit about intellectual property law and to protect the ideas. Without the protection of the ideas, then it's hard to find investors who will help with the translation process. So this is Sir Robin, who is involved in the Institute of Brand and Innovation Law. He does a very good session where we get the students to decide about whether something is patentable or not, and he's the judge in there. I think you've done that session, haven't you, Satan?
Yeah, it was second year, I think.
Second year, yeah. So about 60% of the course is medical science, with a focus on, in the first year, about human biology, and then more specialized scientific topics in the second and third years, like tissue engineering or nanotechnology, depending on what you're interested in. This is areas of strength within our division and the faculty, and areas that I'm interested in as well. Lots of research looking at advanced biomaterials, so improved implants that we can use. That could be breast implants. I was telling Sata earlier that I've just submitted a big grant for improved breast implants, degradable breast implants. That's really exciting. Tissue engineering, where we'll take cells from the body, expand them in vitro, add them to a scaffold, and then grow new tissues. And that could be tissues for improved modeling of drugs outside the body, or it could be for improving functionality of tissues inside the body. Nanomedicine as well as an area that we're interested in. So my area is really looking at how materials interact inside the human body. And that doesn't matter if they're on the nanoscale or larger materials. And if we understand more about how we can control biological interactions, then we can have advanced materials that can do more. So materials that can last longer, materials that can diagnose disease, and materials that can have regenerative properties, so grow new tissues. And one of the motivators for my research is because if you have an orthopedic implant, if you have any kind of implant, then it's going to fail. And in fact, orthopedic implants like hip replacements have a higher failure rate, have a lower failure rate than soft tissues. So nose implants, breast implants. So soft tissues implants have a much higher failure rate. And we think, well, I think, this is largely due to micro movement and modular mismatch between your implant and the surrounding tissue. So I'm interested in creating materials which can do more. And one of these things is to regenerate tissue. And tissue engineering, there's two kind of approaches. There's the outside the body, in vitro approach, where we take cells, expand them in culture, add them to a scaffold, culture them some more, and hopefully get a tissue form, which we put back in the body. Or there's an in situ approach, where we have a material that's been functionalized and designed, and we put that directly into the body. Now, this has the second approach, the in situ approach, has lots of advantages, especially in terms of translation and commercialization. The traditional approach costs lots of money, which is one of the reasons why it hasn't been successful. Now, the challenge with the in situ approach is that you need to release factors in a controlled way to encourage new tissue growth, and that's quite challenging. I'm particularly interested in making bone. These are some group members we have, that's Amy and Azzy, who are interested in bone formation and bone resorption. And we can create some lovely bone outside the body. This is the best bone. We make the best bone in the world, I'm going to say. And then this is an osteoclast here. So if you want to look at bone resorption, so if you think of bone formation, it's a balance between bone forming cells and also the bone resorbing cells. And your tissues are constantly remodeling, so it's important to have the balance between bone formation and bone remodeling correct. And in some diseases, that doesn't happen. So we're looking at materials in particular that can correct that balance so that we have healthy bone in patients that have bone defects. Whole organ tissue engineering. I'm sure you've heard lots about this on the news. We have a quiz. This is the poll, Sata. Let's do the poll now. So when will we be able to grow whole organs from your own cells, and when will they be available on the NHS? Shall I stop sharing?
There you go.
Oh,
You should be able to see the options now on your screen. We've got now, 5 to 10 years, 10 to 20 years, 20 to 50 years, or never. Hopefully no one puts never, because we're hopeful here. But those are your options. Have a think and give us what you Give us your answers. All right, hopefully that's giving you a bit of time to have a look. Let's take a look at what our audience thinks. Okay.
So one person. Oh, you want to do it? Say
No, go for it.
Yeah. Well, one person says now. That's really impressive. We can do it already. I think on national health services is an important caveat here. 5 to 10 years. It's interesting in terms of the media portrayal of tissue engineering and stem cell therapies. It always seems to be 5 years away. There's lots of 5 years. This is coming. 10 to 20 years, 20 to 50 years, or never. Now I'm in the 50 plus years group. I don't want to say never, but it's hard to imagine how this can be achieved. And there's so many different challenges. And one of the biggest challenges is the vascularization. So keeping your cells alive and functional outside the body. And then when we put them inside the body, ensuring that the vasculature is grown. And that's a major challenge that we're having. The bone tissue engineering images that I showed you earlier, when I said we make the best bone, that's about 1 millimeter. And that's 1 millimeter in size because that's the amount of diffusion you can get from oxygen without a vasculature. I'm happy to talk to you more about this afterwards if you want to. So there's lots of excitement about this, but it's still a lot of hype opposed to reality. And that's one of the things that we talk about on the books, about being critical about published research. If you want to listen to a more critical view, there's a crowd science podcast which I was on where we talk about can we make artificial organs from our cells. I give a very critical view, and then I've asked my colleague Giuseppe, who has a company actually making organoids, and he gives a much more positive outlook. So if we have an organ that fails, there are a few options that we can do. We know we don't have enough organs, but there is lots of research into how we can extend the life of the organs or make more of the organs that we do have. So can we have organs that can be transported longer, that have increased viability? Or can we change the immunotherapy so that they can last longer? It's not so much the immune rejection that will kill people or is life-limiting for people who have organ transplantation. It's the use of immunotherapies, which, whilst have advanced hugely, are still life-limiting for lots of different reasons. We can't have artificial organs, certainly not inside the body, and that's largely due to wear, coagulation, and the interaction with our blood and cell systems. So the alternative then is to create our own organs. So you quite often, especially look at TED Talks, you can see beating hearts like this. In reality, this is polymer, a sac, with some cardiomyocytes cells growing on top of it. It has nowhere near the pumping or complexity of an organ. An interesting thing we've seen in the last few years is Smeat, so growing tissues not for regenerating purposes, for medical purposes, but to eat. And I think there is a strong argument that if we could do this, which we can do, so if we take stem cells and expand them and grow muscle and fat and put them together, then we can have meat, then you're saving a considerable amount of land. And as the world becomes bigger meat eaters, when third world countries increasingly eat more meat, which is happening, then we have more deforestation and adverse climate effects. You can actually buy chicken nuggets now, which from there's a restaurant in Hong Kong which will do some chicken nuggets for you, which are derived from chicken stem cells. I'm also interested in nanoparticle drug delivery, and the main kind of motivation for this area of research is, can we get higher doses of drugs to where they're needed, normally anti-tumor cells, so they can have a bigger effect where it's needed and less systemic effects. And there's lots of challenges in this area as well in terms of how can we get our particles to the right places. And I'm particularly interested in this interaction. So in terms of when you label nanoparticles with your particular anti-cancer label, why doesn't it get to the cancer cells? And I think it's due to the non-specific protein interactions. So a bit more about the course and less about my research. So we're interested in building creativity, criticality, and communication. There's a lot of hope and hype in medical innovation as a whole. And there's a balance between building excitement in the field, getting funding for a field, but giving a realistic timeline or building confidence in technologies. I think as a kind of education system, we're not very good in building creativity in science. Whilst if you were to ask academics in science or in pharmacy or research, they'd say that creativity is the most important thing. Unless you're creativity in science, you won't have research ideas, you won't be able to get funding, you won't be able to do your research. And that's also, one of the nice things about being an academic is, being able to work on new ideas. So we talk about how to foster creativity in science, and how to test ideas, how to build innovative environments, both for universities and education, but also in business as well. We talk about criticality. So I think to be able to become good scientists, be able to spot good scientific research and invest in the right products, you have to develop a critical mindset. And quite simply, a lot of research that's published isn't very good. So we spend some time talking about this, and in terms of even assessing you on this. I think Sata's favourite paper was my examination for tissue engineering, where I give students a research paper and then a certain amount of time to write a critical analysis on that research paper. We have small group teaching, interactive online teaching. Each student also has a personal tutor who's there to support your career development, but also help you with pastoral care, welfare. In the first year, there's lots of small group teaching, some in the second year, less so much in the third year when you get on your you're more supported in terms of your peer groups. Some modules are quite large, so we'll join the integrated medical science as a whole. So we're one program in the integrated medical science family, and some modules are shared across the entire integrated medical science groups. So they could have 150, 200 students on them, while some other modules are much smaller, so it might be 20 students, 30 students. The small group teaching is normally less than 10 students. Sata, I don't know, which is your biggest and smaller classes that you've been on in your time at UCL?
That's a good question. I would say my recent module with the School of Management, which was digital communications, was about 160 of us. It felt quite big. We were in a huge room, and probably the smallest would be like the MIE specific courses, being that it's still quite new. There was about 25 of us on that one.
Thank you, Sata. You liked that digital communications module, didn't you?
Yeah, I really enjoyed it. Like, it was completely out of my normal sphere of what I've learned so far, and yeah, met loads of new people and learned loads of new concepts and stuff that I would have never otherwise encountered. Really good fun, actually.
Good. We try and use some real world teaching challenges, especially in the medical innovation enterprise specific modules where we're based in the Royal Free Hospital. For lots of our teaching, we have good interaction with clinicians, surgeons. And so we're aware of like real challenges in the medical need, and we try and base some of our business proposals or teaching based on those clinical needs. And as I said, lots of different types of assessments that we use to try and promote communication to different types of groups. So it could be like more general or scientific groups. Yeah, so assessments, dragons dens, communications, we try and do lots of talking. I know some students are afraid of that, but I think building confidence in speaking in front of people is a key skill that you need to develop if you want to be good in any career. I think there's very few careers now where you don't have to speak to people in public. So we have these online interactive learning platforms where you have somebody speaking, and there's some lectures, some modules that have much more in terms of the taught material is beforehand, and then the lectures are more, or tutorials are more about talking about the lectures or particular tasks, so the knowledge is before the lecture. But there's different styles for different modules. This is the overview of the course years. So in the first year, there's a real focus on the human and basic medical science. With only one module that's kind of more business related, which is medical innovation and enterprise. All the other modules you share with the IMS, with the integrated medical science. Years 2s and years 3, they become more business focused and more medical innovation focused, depending on what you want to do. In year 2, there's 2 core modules for the School of Management, so understanding management and enterprise, entrepreneurship theory and practice. And you have 2 optional modules as well that you can choose from, either business modules from School of Management or more science modules. In the 3rd year, a similar approach where you have some core science modules and also 2 core School of Management modules, business modules. I should mention that the medical innovation enterprise modules, which are just for our students, the NYU students, they're kind of longitudinal, so they're linked between the years, which will finish in the 3rd year with business plan and a Dragon's Den. Is there anything else I can mention here, Sata? I don't think. Oh, research projects. So there's research projects in the 3rd year. So that's 30 credits of 120 credits, where you'll get a whole list of different projects from throughout the faculty, and you choose your favorites and you do that research project. So all these projects are with research groups who want outcomes. They want you to be part of their research group. So it's a really important component of understanding research, which again is good regardless of whether you go into a more business pathway in your career or a more science.
And I think just to touch on what you were mentioning before, especially after 1st year, 2nd year and 3rd year, for any of you who are like, I'm more on the science side or I'm more on the business side, you really get to tailor those next 2 years to how you want it. I wanted to do more business stuff, so I got the opportunity to do that. And I know some of my friends wanted to do more science stuff, and they really had the opportunity to do that. And again, with the research project, it's like you have so much independence in that part of the year. You get to really focus in on one really key aspect. And for me, and one of the people that I was working with on my research project, we were lucky enough to get a paper out of that. That's, fingers crossed, getting published soon. So it's actually quite a big opportunity as well, that you can really get really into lab work if that's something that you want to try, or do more of like a desk-based literature review. Both of those things has quite a lot of kind of flexibility and tailorability, I guess, to the second half of the degree program.
Thank you, Sata. That's good news about your publication. Do you want to say what the topic was that your research?
We were looking at, this is very weird, but the use of eggshell membranes. So like the filmy part of the egg when you've boiled it and you have to peel it off, looking at the use of that for as like a cell culture model instead of using things like agar gel, which we use quite a lot of, potentially as a use of something that's would otherwise be a waste material, but also something that's already biologically compatible. We know it does the job it needs to do in the egg. So hopefully that's something that we can apply to the lab environment and even beyond that, kind of reaching into Gavin's area of maybe tissue engineering and as a scaffold material.
Brilliant. So you have a choice after the third year that you can go on to the MSI, which is the fourth year, which is again 120 credits. You can choose any 3 optional taught modules from either business or medical science. In the third and fourth year, you have the option of doing, so we give you a list of different optional modules, which I've put here, and you can see on the website online. But you also get a choice of doing one module in the third and fourth year of your choice. This is new, Sata. You didn't get this choice from any module from throughout UCL, as long as it's kind of related to medical innovation enterprise. We have another research project in the fourth year, because again, I think it is the research component. You learn so much in terms of communication, project management, team working, and it's something that's really valued, I think, in the employment world. And you also have innovation business consultancy, where we ask our colleagues who are outside of UCL working on medical innovation to provide a project for our students. And that's a consulting project where they'll say, we want to do this or that, and we will ask our students to write a report to engage with that project and produce a consultancy project report. Say, did you want to say what your project is on your consultancy?
Yeah, I'm working with a company called MSD UK, which is a minority supplier development company. They essentially kind of work with ethnic minority businesses to help them improve their startups and then pair them or help them reach out to large corporates who are interested in basically purchasing their product. We've been working on a project to assess the impact of one of their accelerator programs. I've been working with a really great team. We've had lots of weekly meetings and really just getting in touch with the alumni of the program who've done it before, finding out what their feedback is, and producing a report to then kind of publish out to the public and to potential sponsors and any other ethnic minority businesses who want to engage with the program or perhaps sponsor the program.
Brilliant, thank you. I think one of the key kind of goals for that module is networking. So you get to meet lots of different people in medical innovation. It's things for your CV to show that you've had professional experience, but also just developing professionalism, in terms of like teamwork, experiencing professional environment, meeting deadlines, etc. It's good. Okay. Oh, the other thing I was to mention. So I mentioned about the family of integrated medical science within the Faculty of Medicine. And we're one of the courses in this family, and after the first year you can swap. So we understand that choosing your career when you're 18 is quite difficult if you change your mind and what you want to do, but actually I don't really like the business so much anymore, I want to do more science. You can do that. These are the entry requirements. I'm looking at this. I think these need to be updated, don't they? So the grades for your entry are not AAB, that's AAA. They've gone up one. And there's contextual offers as well, which will be, again, will go up one. Well, I think, yeah. Just check the prospectus online, which will be up to date. Employment. So we're hoping the Medical Innovation Enterprise course opens doors, gives you more options than less options. When we talk to medtech and biopharma, they're still interested in employing our graduates, even more so possibly because you've got the medical science plus you've got the business expertise. We have some students who have gone on to do more research in academia, so master's programs, We haven't got any PhD students, I don't think, yet. I'm looking at SATA. I was saying this, we've only had 1 year of third-year graduates. This is more expectation from what we have. We have had 2 students who have been employed in consultancy in life science businesses, I'm aware of. So that seems to be one avenue employment. But it also could be in the knowledge transfer, policy, governance, and hopefully we'll have some students who will develop their own companies. And we're in the environment where you can do that at UCL. We have an accelerator scheme. We have networks to enable students to start them off with their own companies. Good. Well, thank you very much. And you can ask us questions if you like.
Actually, I don't know if we had a student who had started a business last year who has gone on to like expand that business and accelerate it more as a result of participating with us. So we've got someone in enterprise somewhat dipping their toe in there already.
It's true. Lewis?
Mm-hmm.
That's fantastic. Yeah, I mean, he went to Parliament recently, didn't he, to promote his business, which was pretty exciting.
Mm-hmm.
Good.
But yes, make sure you make use of the Q&A function if you have any questions that you want to ask a current student or Gavin as our course lead. This is the perfect opportunity to get those questions out, and we'll be happy to answer them.
Are we able to, if you wanted to, not write stuff down, you could also say it verbally, I think. Can we do that? Okay.
I actually don't know. Oh, yes,
Yes,
we can.
there we go. Okay, so if you just want to raise a hand and ask a question, you can do that as well.
While we have you, actually, I'm curious to know, those of you who've joined us, what kind of place are you at right now? Are you at A-level students? Are you GCSE students? What kind of audience do we have with us today who are thinking about potentially joining this program in future? Oh, we have a question. We'll answer that one first, and then we'll come back. Oh, my laptop's frozen. Okay, someone's asked, how did you know you wanted to do medical innovation and not medicine? Well, for me, specifically, funnily enough, I did do medicine before I joined this program. I will say that the difference being that medicine and kind of the route into getting into it is very tunnel visioned, and so somewhat rightfully so, because you have to focus on, you need to get these A-level grades, you need to get this work experience, and then you kind of get channeled through that at university as well. And for me, the difference was that I got a lot more space for creativity and actually exploring things beyond just the basic science. So that business element was really important to me, and that's something that I didn't really get the opportunity to do at medical school, and that I did with the MIE program. Obviously, then there's the flip side to that, which is that once you finish MIE, you have to go and kind of stand up on your own 2 feet and look for a job in kind of whatever sector that you like. And there is just that exciting, but to an extent, overwhelming sense of you have so many choices. Whereas in medicine, kind of once you finish, you know what you're going to go into. So it is really just about deciding within yourself what that is that you want to do once you finish in 6 years' time. So obviously there is that as well. At UCL, it's 6 years of medical school versus 4 years or 3 years of the MIE program. I think that's the most unbiased answer that I can give you, so that I don't really influence. I think it's very much a personal decision on what you think would be best for you.
I think it is. We have a lot of students who I think are looking at different options in terms of medical school. I think there's parent pressure, isn't there? There's the safe career path with medicine, and you know that you're going to have a job when you complete medicine, which is adds security. But yeah, it's we do have some medical students both in my research group and who come to us later on. So they realise that whilst they like medicine, they've done it 6 years, they're moving away from it because they enjoy doing the research components more. And this is obviously, and that's a long route to get there, to get to the same position that other students that haven't have medicine. The medical degree, is, I think, recognised as being, a sign of a worthwhile merit, intelligence, academic achievement. So it is recognised, I think, in lots of different careers, but it is a longer route, a more costly route to get to the place where you want to go, if you don't want to do medicine, that is.
And again, not to be biased, because I'm really trying not to be, but I will say that obviously, having been in medical school, I have a lot of friends who are still doing medicine or have since graduated and are now doctors. And a lot of them do stay on the path of being a doctor and really get to explore the medical career. But I would say a significant portion do actually then venture outside of that and are almost starting from scratch and learning about what enterprise is, because they are wanting to start their own medtech firms or their own kind of healthcare communications firms. And they're now having to go through the learning curve that I'm getting the opportunity to do now, and understanding what it is to understand like the finance side, the legal side, the business side, all things that are involved in the entrepreneurial side with their scientific background. So again, that's just kind of something worth considering. But as Gavin said, you can still do medicine, come out of that and go down that route. It may just be a longer route, but it may be the right one for you. Okay, so our next question I'll ask Gavin. What are the requirements for the international IB students?
I'm going to share my screen and show you, because clearly I put up the last year's slide as opposed to this year's slide. And I'm going to share my screen and I'm going to show you on the prospectus. So these are, so for you, this is the A-level requirements. The contextual offer is BBC, and you should check out the contextual offers, because, well, you should do that if you qualify for them. And then the IB diploma is 38 points, 30 points for contextual offer. And you need to have a total of 15 points in 3 higher subjects, including biology and either chemistry, physics, mathematics, physics.
There you go. So the other question again for you, Gavin, is how many places do you have on this program? And do you take work experience and or internships into account?
So what was the question again?
How many places do you have on this program?
Yeah, how many places? We have had a bit of a increase in applications. This year we're going to have around about 35 students coming in, and we'd like to keep it around that level. I think it is getting increasing, well, difficult to get on the course, not to put you off, but I think, there is a motivation. The way they decide on places is just on academic achievement. So it depends on if there's more places, if there's less places than available, they'll just rank them according to your marks. They'll keep a certain number for contextual places as well. And then the second part of the question was, can you do internships? So because it's ranked, it's not going to benefit your chances of getting into the course, because it's just based on academic. I think they do that just for transparency and fairness. So we don't, as a program, we don't get to even see many of the applications. It's just all handled by central admissions.
And I suspect that question is coming from people who are thinking of applying to medicine as well as applying to the MIE program, which is understandable, because I understand that there is not a requirement, but a preference to do internships and or work experience for that. Obviously still do those things if you want to apply to medicine, but like Gavin said, it's not going to impact, it's not going to hinder nor be an advantage to the MIE course.
Absolutely. And I suppose the other thing to say is that just, in terms of life skills, it's quite nice to do research, isn't it? And you're doing internships. But I also think, you're only young once, and it's also quite good to have holidays.
Definitely. I agree with that one. My entire summer holidays were eaten up for 2 years. So there you go. Okay, the next question we have is, after the BSc, if you want to continue to do the MSci, can all students progress? Or are there limited spaces with competition to do this?
No, so all students can progress as long as they've passed the BSc to progress to the MSI.
Okay.
And you can make the decision for that up until the end of the 3rd year. So you don't have to make it.
Someone's asked, after this BSc, is it possible to apply for graduate medical entry?
Yeah, so different universities have different requirements for medical entry. I think it's not necessarily the best route to go. is my kind of feeling, is that if you want to do medicine, you should try and do medicine as much as possible. And if it means, like have a look at even doing retakes, because 1 year retakes is better than doing a whole nother course in a different area. And then there's still no guarantee whether you'd get into the graduate entry, because it's still competitive, possibly more competitive than the undergraduate entry. So in terms of is the degree eligible, I would expect it's eligible for all courses. Some medical degrees, postgraduate, don't require any type of, they're not subject specific. So Oxford, Cambridge, you can have any subject as an undergraduate, history, art, and you can still qualify. Some other degrees will be more specific, so it just depends on the university you're applying for.
Thank you. And we have another one asking, could you integrate with this course during medical school?
Could you integrate, to say?
Yeah.
So there isn't an IBSc in the third year. There isn't an integrated medical science. There isn't an MIE integration. There are some courses that do some business studies, I believe, in the IBSc for their third year. And there are also lots of different science-based IBSCs or more surgical ones. But there isn't one specifically for this course, no.
I think, is it the surgical sciences, I want to say? Because I had a friend that did the IBSc surgical sciences, that's with you. Some of the modules overlap, but not the whole course. I think we shared like the tissue engineering and regenerative medicine module, and there's one other that we overlapped, but I can't remember what it was. But there's a bit of overlap, but not the entirety of the course.
Yeah, it's not the kind of business components aren't included.
Yeah. But it is worth noting for any of you who are wondering about integration within medical school, I was going to, before obviously I changed my program, integrate at Imperial. I shouldn't say that out loud, but integrate at Imperial for their healthcare management, which is a lot more of a business-sided course. So again, if that's something that you're interested in, and I think UCL have some business-sided integrated options as well. So again, that's something that you can look into more if that is interesting to you. Oh, we've got 2 questions. The first one is, are MI students actively involved in the research projects for medical sciences department? We'll tackle that one first and then we'll come to the next one.
Yes. So there's lots of different groups. There's medical science, there's more bioengineering groups. So my office here, I have me, and then I have Deepak, who's professor of regenerative medicine, but he does lots of 3D printing of materials. And then there's Professor Wenwei Song, and she's more of a material scientist, but there's also lots of different gene transfer, loads of different projects. So whatever research interests that the PIs have, and this is, across the entire Faculty of Medical Sciences, they will offer projects to students.
There you go. And like I said, mine was within the, what's it called? Dental Institute.
Yeah, Eastman Dental Institute.
Eastman, that's it. Within the Eastman Dental Institute, but it kind of falls under the umbrella, I think, of the medical sciences department. So yeah, I think most people I know did something within the medical sciences department. And in terms of actively involved, absolutely. Like I spent days and hours in the lab doing my own lab work at the bench, kind of with my own pipette and everything. So actively involved is definitely something that you get to do. And you are as active as you want to be. I think I had a great PI, which is principal investigator, where he kind of let me be as engaged as I wanted to be. Obviously, there's still a minimum that you have to do, but if you want to practice a certain technique, or you want to have a introduction to a particular kind of lab piece of work that you wanted to do, that is something that is optional if you kind of have that conversation with your PI and see if that can be included within your research project. Okay, and the second question is, what will happen if the student misses out by 1 grade on results day and could not fulfill the offer condition? Will there be any flexibility at this point?
So it really depends if the university is full. So it depends, as a nation, as a UCL university, if the results that year are high or low, if lots of people have missed their grades, then there's more likely to be places available. As a rule, UCL normally doesn't have many spaces, but there might be some course specific spaces if you miss a grade. So it is worth checking the course if you do miss one.
There you go. Oh, okay, another one is there is a choice of applying directly for the MSci on UCAS instead of the BSc? Is it more competitive / harder to get onto the MSci if chosen upfront?
That's a good question. I don't think there is any difference. We have the total program numbers, so I don't think it is categorized between the MSI or the BSc. We have less people that apply for the MSI, generally speaking, than the BSc, and that's just because I think they think they'll try it and then see if they want to stay on or not. But I don't think it makes any difference. But I can check if you like. But yeah, I'm pretty sure it doesn't make any difference if you do the MSI, BSc. But actually, the total numbers are what counts. Bums on seats.
Okay. We have just about 5 more minutes left. If there are any other questions, feel free to keep sending them through and we will answer those. Just checking if I've missed any. I think there's a question here that we haven't asked, but I think we've answered, which is what are the typical A-level grades that students are expected to have? And from what Gavin was showing earlier, it looks like AAA for the kind of normal entry, and then was it BBC for the contextual offer?
That's right.
There you go. Okay, what are the main differences between this course and the AMS, so the Applied Medical Sciences? Basically asking us after first year, I'm assuming they're asking what the differences are.
Do you want to start, Saita? Well, I'll tell you. The first year is very similar, apart from that one medical innovation enterprise module, which is why you can change courses after the first year. After that, the AMS course doesn't have any business, whilst we have compulsory business components that you have to do. There's also slightly different in terms of the optional modules. So obviously, if you do the applied medical sciences, there's more science, and there's more options in that science area. So you only can do a certain amount of credits per year, and because we have those business components, you have less science components or modules to do. I think in terms of the types like tissue engineering, nanomedicine, we offer those to both courses: stem cells therapy, gene therapy. So like most of the science ones you can do on both courses. There will be slight differences to the program diet. You can have a look on the UCL webpage and you can see the optional modules that are available.
And is it still the case that after the first year, since we share a common stream, there's a slight flexibility in terms of if you want to change the stream that you want to continue on to?
That's right. So if you don't want to do business after the first year and really love immunology, you can go and do the immunology stream.
Does that work the other way as well? Because I'm not sure about the first year. So if you started with AMS and you realize, oh, like the business side sounds interesting from what my peers have said, is that something that you can do?
So this year we have 5, or is it 6 now, incoming students from applied medical sciences. So they've done the applied medical science in the first year, and now they want to come to medical innovation enterprise. I think our lecturer, Amy Lee, must have done an amazing job in that module. And now lots of people have to. So the condition is that you have to do the MIE module as an optional. You have to choose that in the first year.
There you go. If you are wondering between the two, you can have a little taste, see if it's for you, and make a decision kind of near the end of first year. Is that when you have to decide by?
Yeah. So I think there's 2 rounds of choosing. So you can do it after the first term, and that's the best place to do it because for the more specific courses, there might be a prerequisite in terms of the optional module that you choose for the second year. So if you want to do cancer biology, for example, you have to complete the cancer module in the first year. So after the first term is when you should choose. Now, if you want to go to AMS, it doesn't matter. You can do it any time.
Okay, so is it only... Wait, hold on. does it only apply about this in terms of switching from one course to the other, basically? Does this only apply under medical sciences, or can it be with other courses under life
It's
sciences as
only
well?
within the Faculty of Medical Science. It's called the Integrated Medical Science, and there's 5 different courses on there, but it's just those courses. You can occasionally swap between courses within UCL between faculties, but it's very difficult to do because you have to make sure you meet the entry requirements, and you have to make sure you're not at disadvantage to the other students on there. So, for example, if you wanted to do bioengineering after joining UCL, then you still have to meet the entry requirements for bioengineering. There's still have to be enough space on bioengineering, and you might have to make sure that you've got in the first year the physics and the engineering components to ensure that you don't fail on that module. So it's possible, but not recommended. You should choose the course that you want to do.
And hopefully sessions like this answer some of those questions for you guys to give you a better idea of what it is you're interested in, and also what it is the course actually entails. So hopefully we've done a decent job of answering some of those questions. We've got about 1 more minute before we get to our closing. So if you do have any more, feel free to ask them. Otherwise, we will shortly go to our closing kind of remarks and let you guys head off for the afternoon. Any more? Oh, we've got 1 more, I think. Thank you for that comment. That's really lovely. Someone was just saying, I don't know if you can see Gavin. Thank you for the session. It's very informative. We're happy to kind of answer this question for you guys. All right, so that is it. We are going to head off there. I don't think we've got any more questions in. Yeah, so we will leave it there. We have run out of time. And thank you so much, Gavin, for your time today and for going through the presentation with us. And to our audience, if you could please give us your feedback after today's session, that would really help us find out how we can improve, keep making these sessions as interactive as possible and better each year. We'll be sending out a survey, which we'll display on your browser following this event. So if you could please fill that out for us and let us know your comments. And again, thank you all of you for joining us today, for your comments and your questions. And again, to Gavin, and have a good evening, everybody. Take care.
Thank you, Sata. Bye, everyone.